Here is the awkward truth about coding agents in 2026. Every new session starts from zero. Your AI has no memory of what you built yesterday, what bugs you already fixed, or which patterns your codebase prefers. And it costs you every single time. You burn wasted tokens reloading the same context. The agent repeats mistakes it already solved a week ago, and the lost knowledge about your project never sticks around between sessions. 3 hidden costs add up fast. 22,610 tokens per query when you naively load everything. $500 a year in API spend that is mostly redundant context, and countless hours wasted re-explaining the same decisions. There is now a serious answer to this. It is called agent memory, an open-source persistent memory layer for any AI coding agent that speaks MCP. The big idea is memory that survives sessions. It captures every observation through 12 hooks automatically. It indexes everything with a hybrid BM25 plus vector plus graph search engine, and it injects the right slice back into context whenever your next session starts. The architecture is MCP at its core. Claude Code or Cursor talks to a thin MCP server over standard input-output. The MCP server forwards requests to a local worker running on port 3111, and the worker stores everything in SQLite so no external database is required. Here is what you get: automatic capture through 12 session hooks with zero manual effort, 51 MCP tools across the core and extended sets, a real-time viewer dashboard to browse what was captured, a privacy filter that strips secrets before anything touches disk, multi-agent coordination using leases and signals for safe parallel work, and it is Apache 2.0 licensed, fully open source. There are 4 consolidation tiers. Working memory holds the current session in flight. Episodic memory keeps individual past observations. Semantic memory distills repeated facts across many sessions, and procedural memory captures the patterns you keep repeating. Retrieval uses a triple-stream hybrid search. BM25 catches exact keyword matches using classical information retrieval. Vector embeddings catch paraphrases and conceptual similarity, and a knowledge graph catches the relationships between entities. The 3 are blended for the best of every world. And the numbers say it actually works. 95.2% recall at 5 on the LongMemEval benchmark from ICLR. 86% token reduction versus loading everything blindly, and 950 plus passing tests are shipped right in the repository. The default embedder, MiniLM, is a tiny 22 million parameter model from 2021. We are going to swap it for nomic-embed-text. Nomic is a 137 million parameter model with much stronger semantic recall, and it runs locally through Ollama on Apple Silicon with zero API cost. Before we install, here is what you need: Ollama installed and running locally for the embeddings, Node 20 or newer with NPX available, and Claude Code installed and on your path so we can wire it in. Step 1. Pull the embedder. Run Ollama pull nomic-embed-text. It downloads about 270 megabytes. Then smoke test the OpenAI-shaped endpoint with a quick curl request to confirm you get a 768-dimensional vector back. Step 2. Configure the env. Run npx agent memory init to drop a template, then append your Ollama settings. Critical gotcha here: the OpenAI base URL must be the bare host with no /v1 suffix. The client appends /v1/embeddings itself. Step 3. Skip the first run wizard. The worker normally opens an interactive prompt that blocks any non-TTY launch. Write a preferences file with skip splash set to true. The worker will then boot straight through without waiting for input. Step 4. Start the worker. Run npx agent memory with the verbose flag. In the boot log, you want to see embedding provider OpenAI with 768 dimensions, the REST API on port 3111, and the viewer dashboard on port 3113. Step 5. Wire it into Claude Code. Run npx agent memory connect Claude Code. It adds an MCP server entry to your .claude.json file. Restart Claude Code or run /mcp inside a session and the new memory tools are available. Now the dashboard? Open localhost :3113 in your browser. The dashboard tab gives you a live overview with all the key stats. The health card reports the worker's status at a glance, and the top of the page surfaces the first run guidance for new users. Click into the Memories tab to browse every saved memory. Each row shows its type, its strength score, and the source observation it came from. You can filter by concept tag or by recency directly inline. The Timeline tab lets you replay your work. It walks you through every captured observation in order. Each event shows which hook fired and which file was involved. Very useful for debugging when a particular memory does not surface as you expect. Two flags are worth knowing as you go further. agentmemory auto-compress turns on LLM-powered summarization of long observations. agentmemory inject context automatically injects relevant memory into your prompts. Both default to off so your token budget stays fully under your own control. Thanks for watching. If you build something cool with persistent agent memory, tell me about it. I am Omar Hosni. See you in the next one.